So there are two principles. There are two principles that we're going to be using to solve this thing here. You will see it after we've solved it, it's going to look exactly like a quadratic. As soon as we remove this root here, and then it's going to look exactly like a quadratic. So what are the steps to solving something that has a root? Number one, you are going to isolate the root one side and then the things that doesn't have a root one side. So you want the root to be one side, and then you want the things that doesn't have a root also one side. So if we do that, in this case, we are going to take the 3 to this other side. Because it's positive, when it jumps the equal sign, it's going to become what? Negative. So we are going to have root x minus 1, which is going to be equal to x minus 3. Ne? That's principle number one. Group root together. Group root one side. Okay, what do we do with number two? With number two, we want to apply the following principle. Let's look at the principle that I spoke about. If a learner finds themselves in a situation whereby they have to multiply two roots, the principle says, number two, if I have a root of 2 multiplied by the root of 2, if you check this in your calculator says the answer. The answer for that is going to be equal to 2. So if I say root 2 multiplied by root 2, the answer is going to be equal to 1. And then, if that's the case, then it means the following. If I have root x multiplied by root x, I will make the conclusion to say it means that I'm going to remove the root and then I'm going to be left with x. So it means the answer for this one here is going to be equal to what? To x. So we're going to use that into our advantage to remove this root. Now, as soon as you are done, then you are going to square both sides. What do we mean by squaring both sides? It means you are going to come and say, square this side, and then you also square this side. Now remember, what does the square both side mean? It means you are repeating the bracket 2 times. So basically, I am going to have something like this. Root x minus 1 multiplied by root x minus 1. And then this side, what am I going to have? I am going to have x minus 3. And then I'm also going to have x minus 3. Something like this. And then let's look at this then. Now remember, we said if you have a root multiplied by a root, it's going to give you whatever is inside the root. So in this case, what is inside the root? It's x minus 1. And then we also have x minus 1. Meaning that if I multiply this one multiplied by this one, I am going to be left with x minus 1. At the same time, if you FOIL here, you say x multiplied by x, you are going to get x squared. X multiplied by minus 3, you get minus 3x. Minus 3 multiplied by x, you get minus 3. Minus 3 multiplied by minus 3, you get positive 9. Then after this, it's a matter of putting everything one side. One side should be 0. It doesn't matter left-hand side or the right-hand side. So because I see that there are like terms here, I'm going to start by adding those like terms. So I'm going to have something like this. X squared minus 6x plus 9. Then we have x minus 1. Now, because these are 2, these people are 2, and then these people are 3, I'm going to take the 2 to the other side so that this side becomes 0. So I'm going to have 0. And then I'm going to have x squared, which is this one. Now, this x here is positive. When it gets that side, it's going to become negative. So I'm going to have minus 6x minus x. This one here, it's negative. When it jumps the sign, it's going to become positive. So I'm going to have 9 plus 1. Now, if we continue with this, you will see now it's taking us back to what we've been doing all along, which is the quadratic. So we have x squared. This one and this one, they're going to give us minus 7x. These two, they're going to give us plus 10. then it means which we can identify our A because it's in a standard form. We can identify our B. Our A is 1. Our B is -7. Our C is going to be equaling to what? To 10. Then using a quadratic or using a bracket, it's up to you. Let me use the brackets here. So if I use the brackets, I am going to have x and x. I'm going to have -5, -2. Yeah. And then it says which x is going to be equaling to 5 or x is going to be. Now, what's different between this one and a quadratic? A quadratic, remember, it starts from here. So if you had a quadratic, basically you're going to be starting somewhere here. They can give you something that starts from somewhere here and then you are going to end up here. This one, where did it start? It started with a root. We're going to go back to the root again. So when we go to the root, every time when we are given the root, you're supposed to check your answers. We don't check our answers anytime. We check our answers if we are dealing with roots. What do I mean when I say you are going to check your answers? You are going to check the left-hand side and the right-hand side. Ne? How do you check the left-hand side and the right-hand side? Let me use a blue pen so that you'll see. This one is compulsory. This one is the only one where you have to check. Remember, guys, when we're dealing with inequalities, I didn't say let's check. When we're solving for x, I didn't say let's check. But here we're going to check. How are we going to check? We're going to check the values that we have. We have x is 5. We have x is 2. I'm going to start with x is 2 or x is 5. It doesn't matter. You're going to substitute everywhere you see x. Here there's an x. You're going to put 5. Here there's an x. You're going to put 5. And then you're going to check if you're getting an answer left-hand side and the right-hand side. Let's do it so that you'll see. So we have square root of, we have 5 minus 1 plus 3 is equal to 5. Let's check here. If you say square root of 5 minus 1, you can type this in your calculator and check what you get. So you have square root of 5 minus 1 equals to, and then you say plus 3. It gives you 5. Ne? And then you can ask yourself, is 5 equal to 5? Because this side you got 5, even on the left-hand side, you also got 5. So this one, we accept it, it's applicable. Let's try 2. Then we're going to change, instead of putting 5 everywhere we see x, now we're going to put 2. I come and put 2 here. I come and put 2 here. I want to check if the left-hand side is also going to be equal to the right-hand side. So if I do that, I'm going to have 2 minus 1, which gives me 1, root 1. Plus 3 is going to be equal to 2. If you check here, we have 4, which is not equal to 2. 4 is not equal to 2, meaning on your answers here, one of them is applicable, one of them is not applicable. So you're going to tell them what 2 is not applicable. Because then when you substitute it on the original equation, it doesn't give you left-hand side is equal to the right-hand side. Does that make sense?
No.
It doesn't make sense.
Yes.
Okay, guys. So far, you know how to get up until to this, Mus. Using your quadratic or using whatever it is that you are going to get. What is the difference between this and what we've been doing all along? We're saying you've been getting to answers. Let's go back to the top so that you'll see here. Let's take, for example, this one that we did as a test here. How many answers did you get here? You got 2 answers. Agish. You solved for x and then you got 2 answers. You got x number 1, you got x number 2. Both of them are applicable. We don't have to check them. Now, with this one that we are doing, man, what is the difference? The difference is that because you are dealing with a root, you are dealing with a square root. Because you started with something that has a square root. After getting your answers, as soon as you get your answers, you're going to take your answers back to the original equation. On the original equation, you are going to substitute everywhere you see x. It's either you are going to be, let's say, for example, here, agree you got 5. You say, okay, but now when x is 5, do I get the left-hand side is equal to the right-hand side? What do you do, basically? You do this. You come and say, okay, there's x here. You see there's an x here. You see the x? Yeah, you put 5 here. And then you say, is there any other place where I see x? Yes, there's another place where there's x. I'm going to put 5 here. And I'm also going to put 5 here. Now, if you solve this thing here, because this one here you can solve, this one there's nothing that you can do. It's just 5. Nothing that you can do there. You are going to solve this one. If you solve this one, it gives you 5 as an answer. Ask yourself, is 5 equal to 5? Yes, it's true. 5 is equal to 5. It means 5 is applicable. It's giving us an answer. Is it fine, that one? Next, we are going to check for 2. How do you check for 2? Everywhere you see x, you put 2. I put 2 here. I put 2 here. And then I solve for this thing. How do you solve for this thing? You can type this thing in your calculator. If you type this in your calculator, what is it that you are going to have? You're going to have something that looks like this. We have root. You have 2 minus 1. These are inside the root. And then you press replay, and then you say plus 3. You check what are you going to carry as your answer. Answer you have 4. But the left-hand side is 4. The right-hand side is 2. The left-hand side and the right-hand side are not equal, making 2 not to be applicable. 5 is applicable because it gives you left-hand side is equal to the right-hand side. Is it clear now?
Yeah.
It's clear. Let's try the following then. We will see it. The only difference with what we've been doing is that after getting the answers, we need to check them on the original equation to say which are they applicable or they are not applicable. Let's try number 1, and then we'll go back to, we'll try example number 2 then.